The problem says, how many squares are there in shape 15 and how do you know? Morgan, you're going to guess 30. Okay. So shape 15, you're going to say there are 30 squares. And that is a total guess, no rhyme or reason. Multiplying by 2. Say more about that. Okay. Are there 4? How many squares are there in shape 3? 9? I see 4. Where do you get 9? I see 4 right now. Where did you get 9? Oh, okay. But let's go back to shape 3. How many squares are there in shape 3? There's 4 shown, obviously, right there, but I think there's a number different from 4. Is it Damari? Yeah. Okay, wait. I can tell you've got it. You're bursting. Are you answering the question to how many squares are in 3, or are you going for the final answer? Okay, before we get to the final answer, how many squares are there in shape 3? There are not 4. There's 5, yes, because you need to look at the larger square also. That is a square, right? Okay, so 3 has 5 squares total. 4 has 10. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and you're saying this large one makes 10? What if I told you it is not 10?
Isn't what you did with just number 3? Isn't what you did for number 3?
Sort of. Say more. How many squares are there in figure 4? It is not 9. It is not 10. Here's the 10th square. Say it again. For figure 2, that is 1 square. Because this is the only small square and it is the only square that's there. So figure 2 has exactly 1 square. Figure 3 has 5 squares that are made up of 4 of the smaller ones that are 1 by 1s and 1 that is a 2 by 2. What about 4? 12. How did you get that? So how many 1 by 1s are there? How many 1 by 1s are there? Anybody? 9. And what else do we have in there? What other size squares are in there? For figure 4. How did you get, what number did you say? 12. How did you get 12? How many 2 by 2s are there? Show me what squares to put around. Like what should I put together? 4, 5, and 2. Put a border. It has to be a square. What about, let me do this a little bit wider. What about this? That's a square, right? Isn't this another 2 by 2 square? isn't this another 2 by 2 square? And isn't this another 2 by 2 square? So how many 2 by 2 squares do I have? 4. Oops. And how many 3 by 3s do I have? 1.
I don't get 3.
3 by 3, that's just the outside large one. That was our 10th one before. So when I add these all up, you said there were 12, but actually there are 14. So figure 4, there are 14.
Now are we going to do number 15?
So if we follow this pattern, figure 5, okay, what's happening here? Do you see a pattern evolving? And this is a lot of what happens in math. Figure 5, what is the largest square that you can make? A what by what? A largest square.
5 by 5.
No, not a 5 by 5. This is figure 4, or figure 5, sorry.
The
Largest square in figure 5.
Wait, wouldn't that add up to?
It would be a 4 by 4, right? Because each time it's one less than the actual figure number. So it would be a 4 by 4, and there would be one of those, right?
71.
Then we would have a 3 by 3, which how many 3 by 3s would there be? No. 4 by 4. We could actually draw this one out still, and that'd be okay. 3 by 3s. I'm going to make this a little bigger. So here's a 3 by 3. Here's a 3 by 3. Here's a 3 by 3. And here's a 3 by 3. So that makes 4. How many 2 by 2s am I going to have? No? There's 1. There's 2. There's 3. There's 4. 5. 6. 7. 8. 9. So 2 by 2s, there are 9. So and then I go by 1 by 1s. How many 1 by 1s are there? 1 by 1?
Oh.
16. So add those all together. We get 25, 29, 30. Do we see any pattern yet? No? Look at the total number that we keep looking at. 1, 4, 9.
Oh, there's 1, 4, 9.
1, 4, 9. 1, 4, 1. What kinds of numbers are those? We even talked about it yesterday. Not prime. No. What? They are even except for 1. Oh, yeah. And 9, no. What is it we're trying to make? Or what are we trying to locate? Squares, right? 1, 4, 9, and 16 are what kind of numbers? What do you call those? Yes, they are perfect squares. So each time the number of squares increases by the next perfect square.
Can you grow a bit?
Can I what?
Grow up.
So if I have figure 5, it starts with the 4 by 4. Okay? If I talk about figure 15, What is the largest square that I'm going to have for figure 15? A what by what size? No. Figure 1 or figure 2, a 14 by 14. It's always one less than the figure number, right?
I'm just writing the perfect.
So a 14 by 14, there would be one of those. How many 13 by 13s do you think I'm going to have? According to this pattern. 4. How many 12 by 12s? 9. How many 11 by 11s? Okay, and I need to get 14 numbers. I have 4 here. Let's do one more. 10 by 10, there would be... What's the next perfect square number? 25. Next perfect square number would be 36. That's for the 9 by 9s. And 8 by 8s would be a little faster. Come on. 49. 7 by 7s would be 64. 8 times 8. 6 by 6, how many? 81. 5 by 5s, there would be 100. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 14 numbers. So then we would have 4 by 4s. That would be 121. I can see who knows their squares. That's good. 3 by 3. What is it? Who said that? 144. 2 by 2s. 169. And how many 1 by 1s? 14 by 14, which is 196. Okay, that's great, Miss Thede. What do I do with all those numbers? You add all of these together. And if you were to add them all together, the total is 1,015. So be aware when it says count the squares, we're not just talking about one size, okay? You've got to count all the squares in there, okay? Patterns, looking for patterns. Any questions on that? All right, Sean, can you put your hood down, please? All right, open up your books, please, to page 58. Page 58. Woo! How's that brain? Is your brain on fire right now? No? Okay. Now, I have to say, my first prime class this morning, it was a little bit hard for them to be talking out. So again, talk out, communicate, okay? Share what you know, share what you see. All right? Page 58, task number 4, miles to kilometers. I don't know why they call it miles to kilometers. I mean, I kind of do, but when you read the problem, you're like, it really doesn't have to do with that. All right, follow along in your books as I am reading this out loud. The students in Mr. Sanchez's class are converting distances measured in miles to kilometers. To estimate the number of kilometers, Abby takes the number of miles, she doubles it, and then she subtracts 20% of the result. Okay, that's Abby. Renato, another student in the class, first divides the number of miles by 5 and then multiplies the result by 8. Letter A says, write an algebraic expression for each method. So this is similar to what we did a little bit yesterday. Okay. So let's talk about Abby first. All right. And this workbook becomes your notes. So I would highly recommend that you write down things that I am putting on the board. You don't have to, okay? But I think it would be helpful to you sometimes, especially when you're working on homework, just to refer back to something. All right, so the number of miles. How many miles are we talking about for this problem in Mr. Sanchez's class?
5 miles.
5 miles. Does everybody agree with that? Does everybody agree?
This is,
Everybody agrees 5 miles. We're talking about 5 miles to start with. Everyone has not read the problem very well then. Okay? It says Abby takes the number of miles. And she does something to it. Do we know how many miles there are? No.
N minus 20, right?
Well, how are we going to represent these miles? M for miles. I like it. All right, so M is going to be equal to the number of miles. So we start with that. So it's kind of like our 2 columns. We've got M, and then what does she do first to it? Are you sure? Are you guys reading the same thing I am? Okay, she takes the number of miles. That's the first thing. We've got a list, so I think we probably should go in that order. Then it says she doubles it. So, okay, double that. Okay, wait a minute. When I double it, what do I get? How about 2M? M for miles? Okay, so that's 2 M's. Everybody agree? It's not M squared, it's M plus M, or M times 2, which is 2M. Then what are we going to do? Subtract 20% of the result. So let's write it down first. Subtract 20% of the result. I know what subtract means. I kind of know 20%. What do they mean by of the result? No. Of the result, it represents something here. Which result?
Oh, no,
No.
Oh, the kilometers.
No. Subtract 20% of the result. What was our result? 2M. Yes. So the result is 2M. Now, how do I show subtracting 20% of the result? Now that we know that the result is going to be 2M, 20 minus 2M. What do you guys think of that? I see some heads shaking.
Wait, what?
Okay, so you had 2M. It says you are going to subtract from that 2M 20% of the result. I probably said way too much right there. What's that going to look like? All right, let's try this. I heard 2M minus 0.20. Is that what you said? What do you think of that? Okay, but we said we're taking 20% of the result, and we said 20%, and the result is 2M. When you take a percentage of something, what are you doing? What operation? No. Multiplying. So what do I got to multiply that percentage by?
Wait,
The result. What did we say the result was? 2M. So it's 2M minus 0.20 times 2M. Oh, drat. times 2m again. So you have to take a percentage of something. That's your, remember we talked about it a little bit yesterday, that's your discount from the original price. Now, can I simplify that a little bit? So 2m is still 2m. What is 0.20 times 2m? Say it again. 0.4. You might have said it, I just can't hear you. 0.4 m, yes. Are you guys with me? If you take 0.20 times 2 on your calculators, you're going to get 0.4, and that m is still in there. All right? Can I simplify that expression?
Divided by, like, because you're
no, this is kind of like if I had 5x minus 3x, what would the answer be? 5x minus 3x is 2x. So if I have 2m minus 0.4m, just subtract, and what should I get? 1.6m. Okay, is everybody with me? That took a lot, but I think we got there. Okay, 1.6m. That's just Abby. Now we got to talk about Renato. Renato, R-E-N-A-T-O. He did something different. Okay, so for Renato, he divides the number of miles. How many miles are we starting with again? M, yes. So we're starting with m number of miles, and he divides the number of miles by 5. So divide by 5. What is that going to look like? M divided by 5. I know, that's really, really sharp, huh? And then he multiplies that result. He's going to multiply by 8. So what is that result going to look like? Say it again. I think you said m over 5 times 8. Where does the 8 go? Numerator, denominator, off by itself. Okay. I could do a little better than that. You're on the right track. Yeah, 8m over 5, because I could go over 1, and it's just 8m divided by 5. Right? Does that make sense? Just say yes. Just shake your head. Yes, yes, yes. Clear as mud. Okay. So those are the two expressions that the different students came up with. All right. Now, it says use your answer to part A to decide if the two methods give the same answer.
They do. Well, yeah, they could, like, if you used to divide 8 by 8 divided by 5, so it leads to 6.
Okay, so she said she took 8m by 5, and she actually did 8 divided by 5, and what did you get? 1.6 m, and Abby started with 1.6 m. So will they give the same answer?
Yes.
Yes. So yes, they are the same answer. They are the same. Okay, they both got it to it by different methods, but they are essentially the same. Questions on that? I'm telling you, you got to be ready to think in this class, okay? Or at least sit by somebody who's going to talk to you and like, hey, what do you think of this? All right? Turn to the next page. Turn to the next page. Let's talk about swimming pools. Anybody got a swimming pool? Anybody got one? because we'll all come over later today, okay? Actually, the neighborhood I live in has a swimming pool, and I have not been there yet this year. And of course, it's going to be closing, I'm sure, by Labor Day, so not a whole lot of time left. All right, page 59, swimming pool. Here you go. You want to build a square swimming pool. You're like, I do not, but just pretend. You want to build a square swimming pool in your backyard. Okay, so here's where the water is. All right, on page 59. Let S denote the length of each side of the pool. Okay, S stands for side, and it's a square pool. All right. You plan to surround the pool by square border tiles, each of which are 1 foot by 1 foot. So you're going to put these tiles all in here around the pool. Okay? So we need to see and find the area of the border of these tiles. Gentlemen. No, you're really talking about math, right? Yes, of course. Area of the border of these tiles. Okay. So we are trying to see, does each of these expressions make sense for the area of the border of the tiles? Okay. All right. So we have 4 times s plus 1. We have s squared. We have 4s plus 4. We have 2s plus 2 times s plus 2, and we have 4s. Take just, I gotta watch my time, 2 minutes. 2 minutes. And see if you can figure out if any of these are going to be correct or not correct in finding the area of this tile. Area of that tile. We're trying to find the area of this tile right here. Okay? Talk to somebody next to you. Bug them. And say, okay, what the heck is going on here? Got 4 times s plus 1. You got s squared, 4s plus 4, 2s plus 2 times s plus 2, and 4s. Why isn't that going down? There we go. I don't hear anyone talking. Man, your brains must be fried because it's Friday. Okay. Well, when you distribute, what does that give you? Okay. Now, when you look at that border, ooh, that's a good notice. They are the same. Now, but can you look at that picture? How could you figure out the area of that shaded part, which is the border? How are we doing? Is this a bit much? Am I a bit much? Is this a bit much? Does this seem like SAT questions all the time? All right. Like I said, you've got to be willing to communicate with those next to you. All right. So I know it's only been a couple minutes. Just subbed in. Okay. So let's talk about these. As you look at any of these expressions, how do we know they're expressions, first of all? What do they not have? There's no equal sign. That's why we know they're expressions, right? Are there any of these that you feel you know could be the area of this border shaded in red? Or any of them that you know that can't be the border?
The first one?
What about the first one? 4 times s plus 1.
I mean, we had to count the size, right? To get like 4, so it would be like.
Okay, there are 4 sides. Yes, that's a good start. And then s plus 1. Is there a way to show s plus 1 in here?
Well, if you count the size, it would be 4. So like 4 plus 1 is 5, right?
4 plus 1 is 5, yes.
And then you multiply by 4, and then you get.
I don't know where you're getting the 5, though.
Oh, no. 4 plus 4
I'm going to, you keep working on that. I'm going to direct you to s squared. S squared. Where do you see a side that is length s? Where do you see a side that's length s? Say it again. Right here, right? This is s, and this is s. So s squared is talking about the area of this square. And what does that square represent? The pool. So is that going to be the area of the tiles? No. So this is incorrect. Because s squared is equal to the area of the pool, of the water, right? Okay. So this is the water in blue. Okay. 4s. Let's go to this one. 4s. Where do you see 4 s's? The 4 sides. So if I have, let's do a different color. Here's 1s. This is 2, 3, 4. It's not the area of the pool. What is it? Yes. Perimeter. Very good. Yes. You are following the distance around. So this one is incorrect because you have found the perimeter of the pool itself, right? Okay. So now we have 4 times s plus 1, 4s plus 4, 2s plus 2 times s plus 2. We're trying to find the area of this outside. How did you break it up? Did you just leave it like it was? Yeah, what are you thinking?
That the 4 goes inside the parentheses.
Okay. Where am I? Are you talking about this one, this one, or this one?
First one.
The first one. Okay. Say again, 4 goes inside the parentheses. What do you mean?
Like, like they multiply, like.
Distribute?
They distribute.
Okay. He says when I distribute, I get, what do you get for an answer?
4s plus 4.
4s plus 4. Okay. Well, I know I have 4 s's here plus 4. What is the area of this 1 by 1 foot border tile right here? What is this area? It's 1 foot squared, right? 1 foot squared. Did anybody break this outside border into, I don't know, what shapes could we break this up into? Squares? Triangles? You want to calculate triangles like this? Maybe not square. Oh, the corners. Maybe we could make these corners into squares. So what's the area of the corners? What's the area of this right here? It's 1 by 1, right? And so that area is, it's 1, right? Area, that's 1. So what is the area of the corner down here at the bottom? 1. And this is 1. And this is 1. Now, we've got rectangles. What is the length of this side right here? What is the length of that side of the pool? S. And what is the length of this side right here? 1. And so if your rectangle is S by 1, it has an area is length times width, right? S times 1 is going to be S. So this is S feet squared, which means this has an area of S feet squared. S feet squared, S feet squared. So what is S plus S plus S plus S? 4 S's. And what did I not count yet? The ones. How many ones are there? 4. So 4S plus 4 gave me the area of that. So that means this definitely should work. 4S plus 4. That's written just like that. So this is correct. So this is the 4, I'm going to say the inside areas plus the 4 corners. Okay. And this looks like it's going to be the same. How did they get S plus 1? Well, here's your S. Let me make that larger. S plus 1, they're using a slightly bigger rectangle. Here is S plus 1. Here is S plus 1. And here is S plus 1. So this is also correct. And if you multiply the last one, if you distribute, you get 2S plus 2S plus 4. 2S plus 2S is 4S plus 4. And that also is going to be correct. Woo! That's some good thinking. All right. Make sure you have been working on homework 0, what makes you happy, and homework 1. That's that magic math. Okay? All right. We'll see you guys back on Monday. Have a great weekend.